Hello everyone, welcome back to another session by Gamma's Academy. Today we are going to learn what is box plots. Before we move to the box plot, we must understand few concepts like what is percentile and percentages and quartiles. So we will discuss about percentile and percentage, then we'll discuss about quartiles, then we'll go to the box plot. Box plot is used to represent your data in a graph format so that for a larger data set, you are not going to check your raw data every time. You can have a look at a bar graph and you can identify the type of your data. Let's talk about what is percentage first of all. I hope you know what is percentage. Let's say I have a data set that is 1, 2, 3, 4, and 5, and if somebody asks you what is the percentage of even numbers in this data set, so what will we do? We will count how many even numbers are available in my data set. There are 2, and the total number of observation points in my data set are 5. So my percentage of even number in this given data set will be equal to number of meeting characteristics of the interest, that is 2 in this case, divided by total number of observations, that is 5 in this case, multiplied by 100. That's how we get 2 by 5 into 100 equal to 40%. That is percentage. Now what is percentile? A percentile is a value below which a certain percentage of observations lie. Here, I have taken an example. Let's say you have a data set like this 2, 2, 3, 4, 5, 5, 5, 6, and so on. So if I am interested to see what is the percentile rank of the number 10, you can see number 10 is over here. So what will I do? I will count the number of elements below number 10 and then I will divide it by total number of observation points in my given data set. So the percentile rank of x will be equal to number of values below x divided by n into 100. So by looking at this formula, you can easily identify that the percentile rank of any given number cannot be 100% at any given point of time, because if I take the last number itself, there will be n minus 1 numbers below this point, and if we divide n minus 1 by n into 100, it can never be 100%. So my percentile can never be 100. That should be a good point to remember. So let's talk about this data set and we'll calculate the percentile rank for number 10. So that will be equal to 16 because there are 16 numbers which are below 10, divided by 20 because there are total 20 numbers in this given data set, multiplied by 100 will be 80%. So percentile rank of 10 is 80 in this case. Okay. Now if I have to reverse the calculation, if I am interested to see what value will exist at a percentile ranking of 25%. So the formula will be equal to value is equal to percentile divided by 100 into n plus 1. Simple. Right? Let's move on. Now let's talk about the quartiles. What is quartile? If you draw a line and you keep your 25th percentile value over here in this line, 50th percentile value and 75th percentile value. So there will be 4 quarters, 1, 2, 3, 4. So the first quarter is known as quartile 1, second one is known as quartile 2, and third one is known as quartile 3. So the 25th percentile value of the given data set will be known as first quartile, 50th percentile value of given data set will be equal to second quartile, and the 75th percentile value of the given data set will be known as third quartile. The 50th percentile value is also a median. If you can recall, half of my data set will always lie towards left of this second quartile and half of the data will always lie towards right of the data point. So this 50th percentile value will be my median as well, right? And the difference between the value of quartile 1 and the quartile 3 is known as interquartile range, and that is represented by IQR in capital letters. Now, with the help of this percentile and quartiles, we will try to understand what is box plot. Box plot is also known as 5 number summary because we use 5 numbers. Over here, those are Q1, Q2, Q3, meaning quartile 1, quartile 2, quartile 3, and the largest number and the lowest number. That's why it is also known as 5 number summary. So here, as you can see, if you draw your Q1 value, that is quartile 1, or you can say 25th percentile value of your given data set, quartile 2, that is equal to median, or you can say 50th percentile value of your given data set, and 75th percentile value, like this. So you will come up with a box kind of shape. And beyond that, if you extend this line and you keep the smallest observation, that is equal to x is equal to q1 minus 1.5 IQR. That will be your smallest observation within the 1.5 IQR of lower hinge. That is known as the smallest observation within 1.5 IQR of lower hinge. And similarly, at this side, if you keep your largest point, that is equal to q3 plus 1.5 IQR. So that's how you will come up with an box plot. You might be wondering why some points may go beyond this. So those points will be known as your outliers, meaning outliers are those points who can impact the calculation of your mean, median, mode, or anything. So that's how, if you plot a box plot for your given data set, you can easily identify what is your median, how your data is distributed, and where are your outliers. I hope you understood box plots. We'll meet in the next video. Till then, have a nice day.